the idea is that the possibly chemical intrinsic properties of molecules might be associated to the differences in subjective qualities, such as the different colors that we experience. And I'm going to start just like making reference to some historical precedent, like in the spirit of complementary science. And Ewald Hering was an important psychologist, and he was in discussions with the people at his time concerning how do you explain the fact that colors and smells are completely different qualities, right? How do you account for that? And Johannes Miller and also Hering believed that there were qualitative differences in the brain. Miller spoke of specific energies, but when Hering was discussing this, he proposed that it could be chemical differences. So the difference between the smell and the colors that we see are related to differences in chemical substances present in different regions of the brain. This was not the mainstream conception, and still today it is not. What was the mainstream by then was the so-called homogeneity thesis, which is a form of functionalism. The idea that everything that happens in our mind is a function of circuits, complicated circuits, based, of course, on neurophysiological currents, neuroelectrical currents. And so this is an ongoing debate, right? What is the nature of the mind? And I'm bringing Hering here just to present a single idea, which is
Do you need to point that?
okay, yeah, related to his opponent color theories of colors, which is based on the idea that yellow and blue are opponent colors. So you can't have a mixture of these two colors. You can have a mixture of green and blue or green and yellow, but not green and red, which are opponent colors. And if this has a chemical basis, one idea is that maybe the chemical molecule that is associated to a certain qualia, they might have two different opposite states, like conformations or polarizations, or maybe possibly different modes of oscillation. So one configuration would correspond to red, and an opposing configuration of the same molecule would correspond to green. So in that way, you would have a natural explanation of why you can't have opponent colors at the same time. The idea would be that it's represented by a single molecule. So this is like this is the main positive argument in favor of this view. But now let me go back. Okay, this is what I told you now is basically like the main idea. So let me go back now and slowly, didactically try to present some concepts from the philosophy of mind, so that we can understand better what is at stake here. So as I've said, a qualia, right, is a Latin name. It's a plural of quali, and it's basically the subjective quality that we experience. Like right now, you're experiencing if you look at your visual field, what you have. Well, we see different colors. You see a certain structure, right? These quali have relations, right? And the red is above the green or something like that. So, but by quali, we are focusing on these elements. For instance, the colors that we see, right? In the 17th century, there was the doctrine of primary and secondary qualities, which stated that, for example, in the tomato is red. When we look at tomato, we see the redness, and our naive realism would say, oh, the redness is in the tomato, right? It's a property of the tomato. But according to this doctrine, that's not the case. The redness, in fact, is in our mind. And the tomato does not have redness. Tomato has a texture, it has a structure, it interacts with light, it has a certain surface reflectance. And so those are the real properties of the tomato. And there's a causal connection that leads inside our minds for the appearance of redness, which are associated with secondary properties. Okay. Now let me emphasize the view which is called structuralism. This is a very bad name because structuralism is used for many different things. But structuralism in physics and chemistry is the thesis that science has only access to relational properties of things. So if I want to measure the properties of an electron, the electron has to interact with another electron or with my scientific instrument. Or when I look at some object, light reflects on it and generates something in my retina, et cetera, et cetera. So these are all indirect. There's an indirect connection between the object being measured and the information I acquire. And so I think Kant started this view that all properties are relational, all properties that science has access to. Everything that we can measure by instruments or by our perception are relational. And the thing in itself, or an intrinsic property that does not manifest itself in terms of relations, would be outside the scope of scientific inquiry. Okay, so that's structuralism. I'm gonna accept this as a good description of how science works. So I'm talking about structure, and I'm opposing structure to quality, right? In my perception, there's a structure, which are the relations between basic things, which are the qualities, the qualia. Qualityism is the idea that the qualities that we experience subjectively, I'm pretty sure that they're real, right? Not every philosopher would say that, but it seems quite obvious that qualia are real. Qualityism is the idea that these qualities that I experience, somehow I can make an analogy and suppose that they might exist outside the brain, not as a mental property, but that I could maybe say that qualities exist in the outside world, right? So that's qualityism. It's a form of panprotopsychism. Well, let me just skip this. And then there's the explanatory gap, which is also a controversial issue. The way I'm going to express it is by saying that mathematics and intersubjective language can only explain structural properties, right? The relation between things, but they can't explain, in the proper sense of explaining, qualia, right? And the argument, well, there's Mary Room's thought experiment. I'm not going to go through that, but in science, usually, like if we want to explain the heat coming from the sun, what's the explanation for the sun being hot? So then you have nuclear theory, you construct the theory, you have boundary conditions, you test your theory, et cetera, et cetera. And finally, you make a prediction about how light intensity arrives on the Earth in different wavelengths. and you compare your predictions with your measurements, which are also numerical. So you have a numerical theory, right, which predicts numerical distributions of wavelength radiation. And you compare that with the instrument, the measurement of the instrument, and then you conclude that you confirm your theory, and then now you have an explanation. So in this process, we're dealing only with relational, with mathematical properties in the case of physics. Now, the claim is that you can't do the same thing if you want to explain why, when I look at the tomato, there is this quality, which is this redness. Why redness? Why not blueness? Why not yellowness, right? How can you explain that? And the claim is that you can't properly explain a quality, basically because the scientific discourse and also the measurement processes involve mathematical, relational, linguistic linguistic manipulations. And by means of quantitative linguistic manipulations, you can't derive a quality, right? So that's the basic intuition behind the explanatory gap. But of course, this is not like a big problem for science. Why? Because scientists, at a certain point, they will discover when this person is having the experience of redness, what is the brain state that is associated to that experience. So then this correlation will establish what is usually called a bridge law, a psychophysical bridge law, which is like a principle, an unexplained principle for the construction of a theory of how the brain works. But the point is that this theory will be based in principles, empirical principles, which are not explained, but they would be accepted and used in the construction of a new theory. So explanatory gap is not like a big problem for science. It's just science will incorporate this issue, and even though I'm contending that you can't properly explain qualia by means of linguistic and mathematical discourse. Finally, my time is finishing, so I'll have to hurry here. But the issue of identity, right? The mind-body identity thesis is the idea that everything we have in our mental lives are identical to brain states or body states. For relational properties in our visual field, for example, so-called psychophysical isomorphism proposed by Kohler would say that, well, if I'm seeing light and now the light seems to be brighter, that probably is correlated to a process in my brain which has become more intense. So you have this isomorphism between the structure of, in this case, intensity, but also spatial relations and temporal relations can be this isomorphism between mental states and brain states can be established in a more or less simple way. I mean, it's an empirical question exactly how this happens. But if you want to defend a mind-body identity thesis, what are you going to do with qualia? Qualia are identical to what, right? So in the 50s, UT Place proposed an identity thesis, which in fact was not an identity thesis because he was in a certain way reducing or eliminating qualia from the description of the mind. But we're not going to do that. We're going to try to apply the mind-body identity thesis all the way through. So the answer is the following. What if we accept the mind-body identity thesis? What is a qualia? Well, the qualia is something qualitative. It exists. It's real. if we are, physicalists, we suppose that it has to be some physical chemical property. So the idea is that a qualia is identical to a chemical or physical chemical property of some region of our brain. This is the so-called colored brain thesis, which is the if you can go, okay, which is the idea that a color is a property of the brain. But how can that be? I mean, if I'm seeing something red, that means that there's something red in my brain. And you say, well, but if I open your brain and look inside, I won't see anything red. Yes, that's true, but that's because, but that's not a problem, because we have intuition that color is related to light. But the point is that color has nothing to do with light. It's not a property of light. It's a property of probably some chemical in the brain. Because, you can see colors when you're dreaming, right? So you don't need, and our brains are dark, right? There's no light inside our brains. And still we see colors, right? So color has nothing to do with light. And so what is it? Well, that's a thesis I'm exploring here. It's the suggestion is that it's a chemical or chemical physical property of some region of our brain. Okay, so to wrap it all up, well, then there's the issue of where such qualia are located, and it seems to me the best candidate would be in some region of the thalamus, but let's just skip this. There's also the possibility that I've assumed that qualia are a property of a molecule, but it could be something 100 times larger, like in the scale of a cell. So it could be that a cell has properties that are not linked to the chemistry, but are linked to some form of electricity, electrical oscillations. That's an alternative hypothesis that I'm not going to explore here, but just to make it clear that from what I'm saying here, there are different possibilities. So the idea that, let's skip this. So the idea that qualia are chemical is a hypothesis that can be falsified within our physicalist program here. So let me just finish by stating that this view that I'm presenting here, in terms of ontology, it's proposing that the physics and the chemistry that we have nowadays, there's something more to be added to our chemical physical worldview. The world is not just relations. There are intrinsic properties that are not accessible to conventional forms of measurement, but the fact that we are part of nature and that we have access by existing, we have access to a little region in our brains, and these qualitative properties exist, right? And if we want to adopt a physicalist view, that's evidence that our chemical physical worldview should incorporate these intrinsic properties, these qualities that traditional science has not yet considered as a viable possibility. So that's the ontological conclusion. Thanks.
Okay, thank you, Osvaldo. Sorry for the interruption. Does anyone have a question? Yes, Michelle, please.
Okay, so I think the last part of your talk is very interesting, that to bring the mind back into the chemical physical world, because we then reintroduce the observer in the science. And for me, philosophically, that's quite significant. However, there's another parallel debate to this that you might be interested in is Frege in his Grundlagen, I think it's footnote 14 or somewhere around there, talks about, it was someone called Schröder, I think, who said that numbers and arithmetic processes can be identified as, well, he used the word muscle movements in the brain. Okay, so all right. So his so this was in 1884. And Frege reacts to this and he says, I cannot recognize the numbers in this sort of talk. And there's going to be that it might not be a scientific gap, but it might be a philosophical gap with the qualia talk, is that I can't recognize the sensation of seeing red in the location that you've put in the brain, right? So just because on the screen it lights up and it shows that there's some neural activity going on in the brain in this location, when I'm experiencing a red color, I don't recognize red in that, you see? So there might still be a philosophical gap. Well, this was Frege's reaction. At the moment I'm sympathizing with it, but I'm willing to be swayed.
I think I didn't talk much about this, but I've been concentrating on what is called primary consciousness, which are the first features of consciousness that appear in evolution or in the baby that is growing. So it's basically sensations, emotions, basic memory, but I haven't gone into mathematical reasoning and language and moral reasoning, which are usually called higher order consciousness or something like that. So I'm focusing more on the qualitative aspect. But the issue of what is mathematics is a big issue. And I believe that the solution of the mind-body problem, scientific solution in the coming decades, will illuminate something of the nature of mathematics, right? But I wouldn't want to risk any opinion on that right now. But yeah, the charge of psychologism or biologism was made by Frege and Husserl, and but that's the issue. I mean, that's the issue. I mean, psychologism or biologism is trying, to make a comeback in present day mind-body discussions, and it's an open issue.
Olympia.
Thank you, Osvaldo. I think that I think to remember that there was a criticism to trying to reduce qualia by appealing to people with problems of different ways of perceiving, for instance, daltonism. I'm not sure that this is really an obstacle to reducing qualia to some kind of physical property of the brain. I'm not sure. I've never studied that, but I would like to know, what do you think about those cases? I mean, I perceive red when you perceive green, but everything is the same, but our qualia are absolutely different. How do you think about it?
Yeah, I don't think this is really a problem. The idea would be that, well, I mean, there's a difficulty in comparing qualia. There's no way I can be sure that someone else is not, inverting the spectrum of visual qualia or something like that. If a Martian comes to the Earth and he asks, "Oh, what is a molecule?" He can ask some question concerning structure. I can present him the structure or make a model of the structure, and he will have an idea of what the structure is. But if he asks, "What is blueness?" there's not really any way I can use the language to explain to him what is blueness. I can point to a blue object, but since he's a Martian, his perception of of that object is completely different, so he won't have the experience of blue. So this is like an example of why qualities that cannot be captured completely by language. So there is this difficulty comparing what subjectively different people perceive. But in the case of Daltonism, there's a difference not only in the qualitative experiences, but also a structural difference, which is manifested by the fact that Daltonic cannot distinguish two colors that we can, and probably he can distinguish shades of green that we can't. So there are these things, differences that can be easily perceived. So, but I don't think this is a real problem, not at all. But I would have to look at the specific argument.
Thank you. Marabel, sorry.
Thank you so much for your fascinating talk. I really like this approach of introducing philosophy of chemistry into these very, very traditional fundamental metaphysical questions. Something that I worry about with this approach or with your talk is emergence and multiple realizability. So for all we know, the experience of color is something that is not tied to just sort of a molecule in the brain, but looking at different cultures, we can see that some of them can, like in some cultures, people don't learn to pick out blue as a specific color. They learn, for example, to what we here experience maybe as blueness, as like dark or not dark, and just not cut along the lines of blueness, meaning it is a learned property, meaning that there's multiple ways very likely of neurons to connect for that blueness experience. And similar to something like anger, also something that is certainly in some sense shared, but the way molecules of cholesterol distribute across my body is certainly distinct from you or from me experiencing anger even last week. So if we have all these different ways in which this phenomenon can emerge, but also we do want to draw lines around, well, when does it stop being anger? When does it stop being blue? How do we ever map these onto one another in a way that kind of fits with these phenomena?
Yeah, that's a hard question. I don't know how to answer that. I mean, I think it'll be solved. Okay, it's not like a metaphysically hard question, but I mean, we would have to know something better about exactly how colors are perceived for me to give an opinion about that. So I really don't know the answer. I don't think it's a big problem, but I don't know how to answer it in detail to your question. We can talk about that.
And the last one, Luciana.
Thank you very much for your talk. I was wondering, just for clarification, what would be the implications to philosophy of knowing, like it would be something connected with realism, for instance, like you said, if we know the connection, we would be able to make a clear statement that things really exist or not. Is that a possible implication or not? I'm not.
Well, there is, of course, a philosophical discussion in the background. This approach is a materialist or physicalist view. The question of reduction or emergence is an open question, but it's not like an explicitly emergentist view. There is a component of reduction here. And I think it also bears on the issue of realism. Well, one metaphysical issue is whether, I mean, the suggestion is that if qualia really is identical to a chemical property, that means that chemical substances have qualities which are not measurable by relational techniques, right? So I can only assert this from the point of view of realism, right? I mean, if I'm an anti-realist, this claim will have no import, right? So anyway, I think there are many implications, but there are many suppositions, and most philosophers won't agree with my approach here. They will say, no, you're too reductionist, or mind-body identity thesis is not defensible, or as someone, as you started, as Maribel started saying, there's the issue of multiple realizability, which is easier to answer. Oops. Anyway, so.
Thank you, Osvaldo. Thank you so much for your